Greetings to you, dear students. I welcome you to this segment on quadratic equations as a cover up to the work that you covered in the week ending 3 April. I hope you find this interesting. Now, on the screen there is a list of quadratic equations which are carefully selected to guide you through how to solve quadratic equations. But firstly, let us understand what a quadratic equation is. A quadratic equation is any equation which is of the form ax squared plus bx plus c equal to 0, where a, b, and c are real numbers. I'm sure you can see here from 1 to 5, all those equations can be written in that form. And more specifically, look at equation number 3. You can actually add 12 both sides so that you have 5x squared minus 23x plus 12 is equal to 0. Now, I want you to appreciate that a quadratic equation is a special polynomial with degree 2. A special polynomial with a degree equal to 2. So the degree of the polynomial, remember, is the highest power of the unknown. So if we have a polynomial with the degree 2, we call that a quadratic equation. Now, we want to demonstrate here how to solve a quadratic equation. There are 3 methods that are available for us. As you can see, equation 1 through to 2, equation 1 up to 3 are all factorizable. So we can use what we call the factor method, the factoring method for equation 1 up to 3. Equation 4 and 5 cannot be factored. They are non-factorizable. So if an equation cannot be factored, we can use what we call the quadratic formula. Then, or we can also use the method of completing the square. The method of completing the square. Now, I want to be clear from the onset. You need to understand each of these methods simply because sometimes you are required to use a specific method. If you are given a quadratic equation, you will be told, use the quadratic formula to find the zeros. Finding the zeros is finding the roots or the value of the unknown that will satisfy the equation. So that is very, very important for you to know all the 3 methods. Now let us start by the factoring method. How do you solve number 1? X squared minus 2x minus 15 is equal to 0. Like what we did when we were looking at factorization, because the coefficient of x squared is 1, look at minus 15. Consider minus 15. Look for 2 factors of minus 15, which if added will give us minus 2. And those factors I can easily think of minus 5 and plus 3. Indeed, if you multiply these two, you get minus 15. If you add them, try it on your calculator, or you can easily see 3 minus 5 plus 3, you will get minus 15. So what you do, you proceed. So we have our x, we have our x. You see why we put this x and this x? We can see that when we expand, we'll get an x squared. So inside, replace this by the factors that we have established above. So now we use the fact that There is no way you can multiply two numbers and get a 0 unless if both the two numbers are zeros or one of them is a 0. That is the fact that we are going to use now. So x minus 5 is equal to 0 or x plus 3 is equal to 0. This will mean that x is equal to 5 or x is equal to minus 3 as our solution, or the zeros to the quadratic equation. Very simple. Now we move on to number 2. Number 2 simply says 3x squared minus 2x minus 5 is equal to 0. There is a slight difference here now in terms of approach, but basically there is no much difference actually. The coefficient of x squared is 3. So here you have to add another step. You have to multiply that coefficient of x squared by the last number, so that you have 3 times minus 5, you get minus 15. Now you look for two factors of minus 15, which if added will give us minus 2. So these factors are minus 5 and plus 3. Straightforward, right? Minus 5 and plus 3. So what do we do now? Replace minus 2x by these factors. In other words, we are putting minus 5x and plus 3x. You see, that is the replacing that I mean. So that you have a 4-factor expression. So we'll have 3x squared plus 3x minus 5x minus 5 equal to 0. Right. What have we done now? Here what we have simply done is to replace minus 2x. You see, we haven't changed the equation. 3x minus 5x is still the same as minus 2x. But we've rewritten the equation so that we have the expression, so that we have a 4-factor term, a 4-factor expression on the left, which we can factorize by grouping. So we look at this one and we look at these terms separately. So what we are going to have, we factor out the highest common factor, which is the 3x, x plus 1. Remember, when we remove 3x, we divide each term by by the highest common factor to determine what is inside the bracket. Minus 5 x plus 1 is equal to 0. So you see this and this is the same now. So we will have 3x minus 5 multiplied by x plus 1 equal to 0. So using the same approach, we will get here our x is equal to 5 over 3, or our x is equal to minus 1. You see what is happening? Either this is 0 or that is 0. Either that is 0 or this is 0. So if this is 0, it means we are simply saying 3x minus 5 is equal to 0. 3x is equal to 5 when we take 5 the other side. So we divide by 3 throughout both sides of the equation. We get x is equal to 5 over 3. That is what I've done there. I think just for me to illustrate that stage so that you are not confused. Very simple. Now you can also try number 3. I'm not going to do number 3, but basically what you need to do is to rewrite number 3 so that it reads 5x squared minus 23 x plus 12 is equal to 0. Multiply that one and proceed. I'll leave that one for you to exercise on your own. Let us move on to number 4. Number 4 is not factorizable. Why am I saying so? Look at this. If we write 10x squared minus 60x plus 20 is equal to 0. So using the same approach, if we try to factorize, it means we have to multiply 10 by 20 to get 200. Can we find two factors of plus 200, which if added will give us minus 60? Find two numbers. For example, we have 10 times 20. Sorry, let me write where all of us can see. 10 times 20 is equal to 200. But what if we add this? We get 30. There are so many factors of 200, for example, 2 and 100. But there is one condition which cannot be satisfied by those factors. When you add them, they don't give us minus 60. If you find them, please, you can drop me an email. I'll be so happy. It will be a discovery. You can drop me an email. I'll put my email here. If you find them. So in short, I am simply telling you that it is not possible to find those factors. In fact, it's impossible. Because of that, it makes equation 4 non-factorizable. You cannot factorize it. You cannot factorize it. But we still want to solve it. So it then means we need to develop new methods. Which are these new methods? It's either we can use the quadratic formula or we can use the method of completing the square. So, but generally, if you are given an equation like number 4, you can divide it throughout by 10 because you can see just to reduce it. The solution will be the same. So we divide throughout by 10, we get x squared before we do anything. So this equation and that one, they are equivalent. You still get the same solution. Now, what next do we do? I'm going to demonstrate the method of completing the square here. So what you do, make sure the coefficient of x squared is 1. If it is not 1, for example, suppose we have 3 here, you must divide by 3 throughout each term. But because the coefficient is already 1, we don't need to do anything. We are ready to go. But what we do, we subtract to both sides. In other words, we don't want this constant term here to remain on our left-hand side part. So what we are going to do, we subtract it both sides so that we have x squared minus 6x. When we subtract here, it disappears, it goes. It will be 2 plus 2 minus 2. But 0 minus 2, it will become minus 2. Simple. Now, what do we do next? I'm sure in your notes that were posted on Moodle, you are given a list of steps that needs to be followed when you are completing the square. And I'm going to demonstrate those steps. But as you go through this video, please feel free also to look at the hard copy, revisit that part and see if what I'm doing is agreeing with what is illustrated in your notes. Definitely they will agree. Now, so consider the coefficient of x. The coefficient of x here is this one. That is the coefficient. You know, the coefficient is the number that multiplies the unknown. So consider that. What do I do after considering? Find half of that. To find half of that is to divide that by 2. So you have minus 3. Now, after finding half that coefficient, square it to get minus 3 squared. Then what do we do with this? Add this term either side of your equation. In other words, I'm simply asking you to do this. I said add both sides. this one is overflowing, it's coming out. You see what we have? We have to add both sides. These are the simple rules for an equation. You can't do something on the left and leave the right. Otherwise, you will change the equation completely. The equality sign will not hold. So I want you to pay attention to these steps. Find half the coefficient of x. That's what we've done. After finding half the coefficient of x, square that half. You square half the coefficient of x. After squaring half the coefficient of x, add it on both sides of the equation. Very simple. That is how simple it is. How simple it is. Now, this will give us x squared minus 6x plus 9 is equal to minus 2 plus 9, that is about 7, is equal to 7. Now, what do we do? Ladies and gentlemen, we are taking this from the binomial, expanding the binomial term. But I want to make your life very easy here. Once we have this term, I want you to look again at the coefficient of this one. We have minus 6. Divide that by 2 to get minus 3. So that you write this like this. Minus 3. Then you square. But I want you to take note that if you expand this, you get this. If you expand this, you get this. Suppose we had plus 6 here, it will be plus 3 here, because we are simply dividing that coefficient by 2 to determine this. So you have completed the square. So this is equal to 7. So you take the square root, in other words, you are doing like this, and you are doing like this on either side. But take note that when we take the square root on the constant term on your right, you must always introduce plus or minus. I know many students, misses that part. So in short, when you take the square root, on the left hand side, you will simply remain with x minus 3 is equal to plus or minus square root of 7. Take note there, because if you don't put plus or minus, you will lose one of the solution. So with that, it means our x is equal to, we take 3 the other side, 3 plus or minus square root of 7. Ladies and gentlemen, this is how simple it is. But we can as well separate this to have our x. Let me put an arrow so that you see that this solution is being carried over to the other side, like that one. So x is equal to 3 plus the square root of 7, or x is equal to 3 minus square root of 7. If you want, you can actually use your calculator to get the exact the decimal values. That will be 3 plus square root of 7. So my x is equal to 5.66. I'm giving to 2 decimal places, or 3 minus the square root of 7, or x is equal to 0.35. And I can indicate that I'm giving my answers to 2 decimal places. 2 decimal places. This is how simple it is, completing the square. Practice makes perfect. Go and try to look at so many problems so that you satisfy yourself that you are very comfortable with the method. With the same, let's try to clean my screen. Now, let me use the quadratic formula for the same problem. We must get the same solutions. You know, different methods in mathematics, but we must still get to the same answer. It's just like we are using different routes to go to a certain destination. So we divide by 10 like what we did. Plus 2 equal to 0. So what's next? The formula, quadratic formula, says x is equal to minus b plus or minus the square root of b squared minus 4ac divided by 2a. This formula comes directly from completing the square of the general quadratic equation ax squared plus bx plus c equal to 0. So you can do this, actually, just do this as homework. Complete the square of this in order to get this formula. So you take c the other side, you find half the coefficient of x, you add the square of half the coefficient of x on either sides. Very simple, just like what we did with the numbers. Just do it on those a, b, and c. You will get that one. I will leave that one for your homework. So with this formula, the most important thing is to identify what is your a. So a is the coefficient of x squared. In this case, our a is equal to 1. Our b is the coefficient of x is equal to minus 6. Our c is equal to 2. You see, that is very, very important. B is minus 6. So we substitute. X is equal to minus 6 plus or minus the square root of b squared, which is minus 6 squared minus 4 AC all over. Some people have got a tendency, I know it's not you who are listening, but I know there are some people with a tendency of not completing this. They leave their line there. This is mathematically wrong. It's no longer the quadratic formula, actually. I don't know what it is. But make sure your line goes up to the end. So this will give you 6 plus or minus the square root of 36. You see, 6 squared is 36 minus 8 over 2. Very simple. Which is equal to, carrying it over to this side, 6 plus or minus 36 minus 8 is actually 28 over 2. Someone is saying, but we never got this answer from when we used the method of completing square. But I think we got the same answer, because 28, you see, the square root of 28 is the same as the square root of 7 times 4. You know how we. So when we have this 4, we can find the square root of 4 actually is 2. So we can move that one out. So this is the same as, let me put here so that you see, 2 square root of 7. You see, it's like that. The square root of 4 is 2. So we move it outside of the square root. But 7 will return. So we can actually write this as 6 plus or minus 2 square root of 7, but we are still dividing by 2. So this 2, you see, will divide 2 into 3. 2 into 6 is 3, plus or minus 2 into 2 is just 1. We don't write 1, we will just write square root of 7, which is exactly what we had. So our final answer will be, my screen is not that big. Our final answer will be 3 plus square root of 7 or 3 minus square root of 7 as our solutions. If you want, you can put on your calculator to get the same numbers that we got, but I'm comfortable with them like that. It's actually exact. But sometimes the question, pay attention to what the question requires you to do. You may be give your answers to 2 decimal places. So this is not 2 decimal places. In that case, then you need to use a calculator. But if the question does not specify the form in which you must leave your answers, I would prefer them like this because these are exact. Remember, we lose some accuracy when we round off. So ladies and gentlemen, what have we done? We have demonstrated the use of the method of completing the square. We have demonstrated the use of the quadratic formula, and we have demonstrated the factoring method. Let us see, before we conclude, I want us to look into one concept which is very, very important. There is what we call the discriminant. Discriminant. I'm not going to do number 5. Someone is saying, oh, but do number 5. Sorry, I'm not going to do it. Discriminant is D, normally represented by D. So what is the discriminant of a quadratic equation? This is very, very important. D is actually B squared minus 4AC. B squared minus 4AC. This expression, which is under the square root when for the quadratic formula, is what we call the discriminant. Why am I introducing this? We can use the discriminant to establish the number of roots and also specify the nature of the roots. What does it mean? If D is equal to 0, suppose you find D, you establish it is equal to 0, it means a quadratic equation has a repeated root. Repeated root. I hope you understand what I mean here. You will find one root which is repeated. For example, x is equal to 2, but you put in brackets twice. In other words, the solution will be x is equal to 2 or x is equal to 2. It's a repeated root, but we don't write it like this. We write x is equal to 2 twice. Especially when D is equal to 0. That is the implication. Now, what about if D is greater than 0? D is greater than 0. It means we have got two distinct. Distinct means different. Two distinct roots. Two distinct roots. Two different roots. Two distinct, let me put another word here, real. Real. In other words, the roots are actually numbers. Do we have some roots which are not actual numbers or real numbers? Yes, we do have. You know, when we say two distinct real numbers, you know the set of real numbers, plus or minus. These are the numbers from minus infinity up to infinity, like that one. So those are real numbers. So if D is greater than 0, we have two distinct real numbers that are coming from this set. Now, what about if D is less than 0? Because all these are possibilities. D less than 0, it means we've got imaginary roots. Imaginary roots. What are these imaginary roots? The solutions are not part of real numbers. They are not part of real numbers, but they are actually part of what we call complex numbers. You can check what are complex numbers. It's part of complex numbers. In other words, you know the square root of minus 1 is actually equal to I, where I is a complex number, and the minus 1 is equal to I squared. This is beyond the scope of our work, of our course, but basically I want you to understand that when we've got D less than 0, our roots are actually complex roots. There are two complex roots actually. That is what it means. Let me use this concept to determine the nature of the roots of number 5, which I did not solve. I just want to illustrate to you this one. Okay, I'm going to clean. No, I'm going to clean. We said D is equal to B squared minus 4AC. Now, what is my B? B is equal to minus 7 for equation 5. A is equal to 1. And C is equal to 15 plus 15. So B squared minus 4A is equal to minus 7. I'm just substituting squared minus 4, 1, 15, which is equal to 49 minus 60, which is equal to minus 11, and it is less than 0. Minus 11 is less than 0, true, yes. So the equation 5 is 2 imaginary. Is this the spelling? No. 2 imaginary roots. Ladies and gentlemen, thank you very much for your time. With this work, I can confidently say, if you practice and you master the concepts very well, you are ready to respond to solve any quadratic equation using any of the methods: factoring, quadratic formula, and completing the square. Meet in the next tutorial. Thank you very much and enjoy.